In this video, I'm going to introduce the attack optimization project. So I'm going to go ahead and run it here. So over here I have this white triangle. This is supposed to represent my little ship. The green is just sort of its visual cone. That was me just more doing an experiment more than anything else. First I want to show you what the ship can do. So it can move to the left. It can move to the right. And I have ballistic controls. That means it's going to drift. There's no friction, so it's kind of imagine that it's like a spacecraft of some kind. It can go forward. It can go backwards. I'm already decelerating to move backwards. All right. And then lastly, it can rotate. So I can rotate left, I can rotate right. There's no drift in the rotation. Right? And my goal, this is my target right in the middle, this little white circle. My goal is to shoot the target. Now, for the player controls, I don't actually have it implemented where you can shoot, but you can see how I'm kind of rotating around it where I'm trying to face inward. So what your goal is to do is to write a system. Could use genetic algorithm, could use a hill climber, could use something in between, to create an AI that will tell my ship how to target this object in the middle. And there's a default setup, so let me show you what that looks like. So all I'm doing right here is turning player control to false, so that it'll be computer controlled, and I'm shortening how long it's going to run. And 20 should be your default. Basically, you want to write code that's going to land the most shots that you can land on target in 20 seconds. So here's an example of what that might look like. Also, the little red dots that you see are where it's either pushing in one direction. So if it's got a red dot to the side, it's moving sideways. If it's got a red dot behind it, it's moving forward. That's the idea. So you can see it's shooting out these little white dots every once in a while to try and hit that target in the middle. And the circles are now actually working. I'm going to run it again. The circles are now working. Here's how this works. Currently, the way it's set up is depending on how far distant the ship is from the target, it'll use a different behavior, right? And the circles indicate sort of these levels of distance, right? This is the closest in the middle, and this is intermediate, and then further and further and further. So each time it crosses one of these boundaries, you might see that it changes which like engines are firing, right? So now nothing's firing, and then the left and right, and then it's sort of oscillating back and forth. And then it changes what its behavior is, right? It rotates around when it hits this ring unless it's already facing the target. So we've got 4 different files. There's only 2 of them that you should probably be doing anything with. So there's bullet class, and it's a physics object, and it moves forward and it draws itself. Very simple. Please don't mess with that. The physics object does some things like how many radians are in a circle, normalize an angle, so it makes sure that an angle is between negative pi over 2 and pi over 2. It's got a physics object class that has some velocity and some angles and rotation rate and stuff like that. Oh, I'm sorry, there actually is a small amount of friction, but it's pretty light. It's hard to notice the friction. Please don't mess with the physics object either, at least not for this project. Now the player, if you want to make some modifications later on, the player can be a fun place to do that. So the ship itself is the player. It is a physics object. It has how many frames between shots in a burst. It has a burst countdown, so it knows it's counting down to the next shot. How many shots it's fired in this current burst. The burst limit, so it currently gets 3 shots per burst. The cooldown between bursts is currently 120 frames, so it's actually kind of a long cooldown. And then the countdown before it's ready to shoot again. So since it has a long countdown between bursts, it has to make sure that it's on target for that next burst. It's got some stuff for its acceleration, what it's doing. It keeps track of the target, stuff like that. Here's a very important thing though next. Self.attack pattern. This is a really long list that I split up into multiple lines to try and make it easier to read. So there's all these distances, right? So this is the first distance, and its action radius is a variable away from that target. And then the second distance, the second action radius away, so it's 2 times action radius away from the target. And basically what's going to happen is, if shoot is 0, it's not going to shoot at this distance. If shoots 1, it'll shoot if the cooldown is done. The -1, I believe, means it's going to, yeah, so forward or backward. If this is 0, it won't move forward or backward. If it's 1, it'll try and move forward. If it's -1, it'll try and move backward. The yaw, which is the side-to-side motion, if it's, oh yeah, it'll detect which yaw direction will bring it closer or further away from the target. So if you want to yaw closer, you should put 1, and yaw further, put a -1. But again, you're going to automate this. This is like my default that like barely works. It gets some shots on target. It's acceptable, but it doesn't do a real good job. There are ways to make it better. And then lastly, whether you should rotate toward, away, or neither from your target. So 1 is going to be toward, -1 is going to be away, and then 0 is going to be neither. And this is your initial list, and it has a certain number of intervals, right? This is that first action radius distance away, the second, the third, I don't know why it's called 2. Okay, 0, 1, 2, 3, and so on. And it goes actually down to 9, right? And it has all these values here. So this is like the default. It works acceptably. When you create a player, this gets created as the default attack pattern. But before we dive any more into that, let's talk about the main file. So you actually shouldn't need to deal with any of this stuff up here. This is initial setup. This is the function that gets the user input. There's some more functions to handle events and draw and delay and all that good stuff. Let's scroll down to the very, 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 very bottom. Okay, so perform experiments. That comment shows you where you're going to need to pay attention, which is right here. And I have just this example set up. I create a temporary player. I copy, or actually just get a reference to its attack pattern. And then I pass that pattern to this experiment function. And I'll say why I do that in just a second. And then I also pass visual, which is just a true or false value. If it's true, I do a visual run. If it's false, I do a much faster non-visual run. So you're going to want to use false here, or just set visual to false when you're actually optimizing, because it'll run a ton faster. And then whether or not it's player controlled. And again, if you set this to true, you'll be able to control with the keyboard. And if it's false, it'll be automated. It'll use that pattern that you saw in the player file. It'll use this attack pattern right here to determine what behavior to do. Okay, experiment is a really important function. You can read it if you want. It's in main. It's right here. But the key thing that I want you to focus on is that it returns the number of points, which is just hits on the target that this pattern got, right? So inside experiment, you actually create another player. This is kind of a contrived, weird way I did this, but if you create a player, it automatically creates that first attack pattern. You can get a copy of it, and then you can pass it to the experiment to see how well that attack pattern does. This is handy because I could do something like pattern 1 bracket 4 equals -1, right? I might be changing the value of this attack pattern, and then I can run this experiment again and see if, call this points 2, see if it got more or fewer points than last time. So you could set up sort of an optimization, a hill climbing optimization like this. Now you'd want to automate it, of course. You don't want to change index 4 by hand, see if it's -1, see if that's any better, right? You'd want to automate that. But this is the basic idea, this is me creating the default pattern, seeing how many points that pattern gets. You're going to want to fill in your code right here. You're going to write either a hill climbing optimization or a genetic algorithm or something in between that creates patterns, modifies them in some way, uses the experiment function to see how good they are, and then tries to create the best attack pattern possible. And there's some extension options that you can make to this project that are described in the README, which is shared with you. You have access to this. It's in the class folder. You may want to modify the physics or the way the ship controls. That would be an interesting extension that I can give you some extra points for if you choose to do. Probably talk to me about what your idea is if you're going to choose to do that. But what you have to turn in is commented code, a list of any modifications that you made outside of main.py if you changed anything else, And then you should also be able to run your code in two different modes. One should be the optimization mode, in which the computer learns what the best pattern is, the best attack pattern. And then a visual mode that shows that best attack pattern in action, right? I already have it set up where you can run both the visual and non-visual modes. That's not what I want you to do, right? I want you to set up where when it's non-visual, it optimizes, and when you can easily set it up so it runs your best attack pattern, and I can see how well that does. So I hope this gives you a clear idea of what you're trying to do in this project.